In this video we're going to show how to complete the 2009 orthographic projection question using Solidworks. So as we can see here, our section B question 1 for orthographic projection presents a pictorial view of a data projector. We are asked then to draw an elevation in the direction of arrow A, project a plan from that elevation which will be directly beneath that, and project an end view viewing in the direction of arrow B, which will be placed on the right hand or the left hand side of A. Okay, so if we start, we can open up our Solidworks program. Just go File, New. I want to open up a new part. In this case, it's easy to have both the link from the State Examinations Commission, okay, for our 2009 question open, as well as our Solidworks, and we can just interlink between the two screens. So we'll need the measurements from our question, okay, as specified, so that we can create this on Solidworks. If we look at our question again, okay, see, we need to consider where the most amount of our information that we know is, so we can produce this easily on Solidworks. And in this example, I believe that the best option we have is looking in from arrow B, okay, our end elevation, where we can see our platform, okay, of all this end view. Now we will for now eliminate the idea of the cut, and we'll just draw this as a complete platform, that edge. So we will have a full length of 35, 60 and 25, which is a total of 120, and we'll have a maximum height of 50 millimeters, like so, of that 38, 12 and so on. So what we'll do is we'll just start creating this. I'm going to go to my right plane, I'm going to view normal to, and I'm going to start sketching with a line. Okay, I'm going to start at my origin point just here, project that out, that line. Okay, we're going to talk about approximately 120 millimeters. Projecting up, then again we can do all our smart dimension afterwards. We're just going to lay out the basic profile of this. Projects down to a point here and now. Escape off that. Using smart dimensioning then, I'm going to smart dimension our lines, and this is all in millimeters. We have 120. This edge here is up 38. At maximum height from here to here is up of 50. Extends up for ourselves. This middle section here has to be 60 millimeters in length. The distance between this point and the edge point here, we can see from our given question view, is 25 millimeters. And the edge height over here, this is also 25 millimeters. And you can see now that our sketch is in black and it's fully defined. That's what we want all our sketches for, fully defined. So I can exit that, and what I want to do is I want to go Features and Extruded Boss Base. Oh, that was my fault. We should be in an open sketch first of all. So just have your sketch open, click into that. I'm going to go Features, Extruded Boss Base, and I'm going to extrude this object out. The total length of our data projector, which as we can see in our question is 140 millimeters. So I'm going to extrude this by 140 millimeters, like so. Click OK to that. Alright, so that is the basic setup of this. Our profile here that we'll see extruded back to our right plane, that is the setup of this. I'll continue with that. On that, so what I want to do is I want to actually click that surface, and I want to sketch on that surface. So once I have the surface selected and the sketch surface, I can just draw my rectangle on that, which we can see there is a cutout of that data projector. There's a screen, or not a screen, but just a vent there of in rectangular shape. Now if you press the space bar, it always shows up the orientation option for you, and if you double click normal to, you can view straight at the view that you're drawing on. So I'm going to go smart dimension, and we want this to be 28 millimeters in height. It needs to be a length of 60 millimeters, and it's lined up exactly with this point here, like so. Okay, so we could do one of two things. We could smart dimension it so that it's exactly in line, or you can indeed add a relation. So I think I might just show you how to add a relation. So in display and delete relations, you can add a relation to make sure that this point and that line, your options here, that they will be coincident. Okay, and that's what we want. So the coincidence is they lie along the same edge. So that is our two endpoints here, like so. They are both defined, and also that this point would be coincident with this point. So again, if we just go add relations, so it's the same idea. You can use relations or you can use actual dimensions to make sure that they are aligned. It'll become over defined. Okay, we'll cancel that. So we want to Control Z allows us to undo. Out of that. So there's an issue with that. Let's see what the problem is. Okay, so instead we'll just smart dimension it to be exact. And the smart dimension is that it is 12 millimeters away from this edge. Like so. So you can see it now is in fully defined, it's on that edge, and we have a rectangular sketch. So we want to go features, and we want to cut that sketch back a distance of 5 millimeters. If we look in our question, okay, that is recessed back in here 5 millimeters. We can tick the green arrow to that, and that's okay, and that's showing that cut out like so. Alright, for ourselves. What we also have in our question shows us that there is a splayed edge on this. Okay, that is cut off at an angle. So it goes a distance of 30 millimeters along our front surface and 15 along our side. So what I will do is I'll create that and show you how to do a cut surface. So what I want to do in order to this, I want to view straight down on the object. So I'm going to select my top plane and I'm going to go normal to, so I'm looking straight down this object, and the line is being cut from here to here. So I simply want to insert a line, and I'm just going to pick a random line, pick a point here, and I'm going to draw to that edge, viewing straight down on that. Smart dimension that. I want it to be 15 millimeters away from that edge as our question specified, and I want it to be 30 millimeters away from this edge as our question specified. So you'll see it's fully defined, okay, but it is just a line on the very base surface. That is what I've created, and using that then I can use my feature. I can do an extruded cut, and the option shows up like so. So I will cut away everything in relation to that line. Careful to make sure that our arrow is pointed outwards, because if it was inwards and we flip side the cut, we'd cut away all that material. We don't. We want to cut away from here outwards. So we can just select OK, and that is that angle taken off for us. If we look at our question though, the exact same angle is taken off on this far side. So instead of recreating that image over here, what you can do through Solidworks is a feature called mirror. And mirror is exactly like an axial symmetry in transformation geometry. So in order to do that, my right plane, which we can see here as it highlights up, okay, my right plane, if I create a plane that is exactly halfway between this side of the object and that side of the object, I'm able to mirror the exact feature that I created here across. So if you select your right plane and you press the control button on the keypad and you just drag from that, then you can drag out an image. Okay, that gives you a new plane, which would be plane 1, and we want that plane 1 to be over a distance of 70 millimeters. Okay, exactly halfway. So that plane 1 is inserted like so. So in creating my feature, what I do is I come up here to the top of my command manager, I go mirror. You have three options. So you have three things to select. You have to mirror the face or plane. So what are you going to mirror around? We're selecting plane 1. And then the features to mirror. We want to mirror what we created last time here, which was our cut or extrude 3. And you can see if we look at the top profile of it, it just exactly reflects across this feature, across our middle plane, onto the other side. So if we just select the green tick, that gives us that like so, mirrored across our plane 1. So going back to our question, what are we left to complete? We have a circular button on top, and we have our features, the curvature features on the front. I'll complete this button on top first of all. So if we look at the details of that, it is a distance from our left hand side of our image in 35 millimeters. There's a diameter of 34, because we have a radius 17, so 2 times that is 34, and it's extruded up a height of 8, and it's 35 millimeters from this edge on the top as well. So using that information, go back to SolidWorks, I select the surface I want to sketch on, I select sketch, and then I use my space button to view normal to. What I want is a circle. For now I'm just going to plot a random circle at a point, and then I'll use smart dimension in order to fully define this. So 35 millimeters away from that edge, and it is 35 millimeters away from this edge. The diameter of the circle is at 34 millimeters. You can see it's fully defined, and we want to create a feature of that, extrude boss base, and that's going to come up from that surface. We can see our directional arrow up a distance of 8 millimeters, like that, like so. And we have this feature created. Finally then, what we want to do is we want, like the shutter buttons on the front and this curvature, we want to be able to complete them. So in order to do that, you need to be able to draw on this surface. What we're going to do is we're going to insert in a plane. But I think the way we have it set up, because we use this point as our normal, they should sit both on our front plane. So going back to SolidWorks, if I look at that surface, that sits exactly where my front plane is. Okay, so just to avoid any confusion, before I do that, this plane 1, I'm going to right click, and under this option of the goggles, I'm just going to click hide, so we don't see that. So I want to go to my front plane, and I want to go sketch on that, and I also want to look at it normal. So I'm viewing straight in at that. What I'll create first of all is I'll create the two circles of radius 17 and radius 14. So if we look at this, these are the ones that are going to project out 20 millimeters from that surface. So we have a radius 17 and radius 14, leaving all this space free. There's a recess there. So if we go back to our SolidWorks, again we want circle, and it's a shared point. If we just go back and highlight that in our drawing as well, the center point of this is shared exactly on that point, shared there. So if I go back to SolidWorks, I'm going to right click first of all, or I don't even need to, it automatically shows up my center point, so I shall use that. Draw my circle 1 and draw my circle 2. You can smart dimension them then. So we want diameter 34 and diameter 2 times 14 is 28. Like so. You can see they're both fully defined. Now if you hold down the very middle part of your mouse and you can rotate that around, you can see that's the profile we've created. Our two sketches on that same front plane. And what we would like to do is go features, extruded boss base, and you want to extrude out just the area between our two circles, and that wants to come out a distance of 20 millimeters, like so. And click OK. So this is what we have created, just like that. But you can see there is a void. You can see the gap between here and here. And in our question, okay, there is a further semicircular arc that is created there, and that is projected back, so that space isn't actually void. There is a solid surface in here. So I shall now create that. Again, it is on my front plane. So I go front plane, sketch, and I will go normal to. This time I want using the same center point to create a semicircle that is of radius 21 millimeters. This here, our pointed, is radius 21 millimeters. So I shall go, in order to create a semicircle, there's two options. You could create a full circle. Okay, I'll show you the two options. You could create a full circle. Escape like that. We could draw a line from halfway point here to here. That's like dividing it, so we have two semicircles. And then I can use the option to trim into these to closest and just cut away the bottom half. That's one option. Okay, just to show you the other option, what you can do is you can use the line command. So I could just draw a random line like so, and then move away using the line command, but don't click. Return till it highlights at the point, and then project that around, and that shows a semicircle like so. Escape. So what we would like to do is I'm going to right click on this, select the midpoint of this line, and I want the relations of that midpoint and this circle to be coincident. That center point want to be actually incorrect option. We could make the two semicircles, would be best to make them coincident. Alright, so I'll actually delete this one, and I'll just use my circle option here, okay, because it's that little bit quicker or easier to understand instead of adding all the relations. So just put in my center line, trim into these, and you're trimming to closest, so it stops at the next point, and we just want to smart dimension that to a radius of 21 millimeters, like so. So we have our profile created exactly there, and what you want to do is you want to go Features, Extruded Boss Base. We want to go in the opposite direction, so we can reverse that, and instead of going blind, what you want to select is up to next, so it goes up to the next surface like so, and you just click your green arrow, and that is you having completed the modeling of this question. Alright, and once you have that completed, you can edit it as you wish. Okay, you can view it. So if we go front plane, normal to, that's what we see from our front view. We can change our display style to show our hidden detail of the recess 5 millimeters here at the edge, or the line at the back edge. We can look at our top plane. We view straight down on top of this. We see our hidden detail of the circle radius 14 on the inside, and also our rectangle here. And you can show your right plane. You view normal to, looking straight in at that, you see your hidden detail, like so. At this point then, okay, before I conclude this video, I'd encourage you to go on and create a new drawing from that part assembly. Create your drawing of that, and then you can verify that using the marking scheme, okay, of the, to make sure that we have this correct, okay, and laid out your orthographic projection.